Well, small Texas town, so he does like country music, but he's kind of like the no boots, but yes, a truck kind of guy.
All right, there we go. Cool, yeah, thanks for that intro. Yeah, my brother wears cowboy boots, my dad does sometimes, maybe to church, but I don't go that far in the cowboy scene. All right, so yeah, I am speaking about web workers and React today. Already heard an introduction about myself, but I'm a full stack software engineer at Pluralsight. I do have courses online on Egghead, and you can catch my slides for my talk today on my Twitter, which is I am Tyler W. Clark. Just to kind of give you an overview of what I'm going to be talking about today, there's four main parts. First of all, I'm going to talk about what are workers in general, both web and service. And then we'll go into some demos with Create React App for both a service worker and a web worker. At the end, I'll give you some tips and tricks and additional information about both web and service workers. I think any great talk starts off with a good why statement, just to help convey the importance of why you should even care about this. And this is a quote that I took from Jeff, who's on the Google Web team, from a video that he said when talking about service workers. He says a service worker, when it's properly configured, makes a web app fast and reliable. And after Hussein's talk today, I could just say what he said too. Because part of having a great user experience is having a fast and reliable website. And when you work with workers in general, if you do them the right way, it does give you that value for your app. And then this actually just posted yesterday, so this was a late addition to my talk from Andy, who's also in the Google team. He's quoting a case study by Jeff, who's said that why statement before, but they just shipped out support for service workers in the Google search, which ended up having 50% less JavaScript downloaded. It reduced cache churn, lots of really nerdy technical stuff in this case study, but the gist is the search team wasn't using service workers. They didn't think that it was valuable. They switched to use service workers. There's a whole case study on it, and they saw just really amazing results from it. And 6% doesn't seem like a ton, but when you think about how many people are Google searching, it's a ton. I do want to spend a couple slides just to get our terminology right, because when I was learning and getting into this space, it took me a little while to understand the difference between a service worker and a web worker, and what are workers, are they all workers and whatnot. So it doesn't really matter, but for my talk, it might help you learn a little bit better to know what I'm talking about. Both web and service are considered workers, and we'll talk about what a worker in general is. And then if you hear me say dedicated or a shared worker, that is a web worker, and a service worker is itself a service worker. Sometimes I hear service workers be called web workers. It doesn't really matter, but you might get confused in my talk, so just wanted to make sure everyone was on the same page. So in general, what are workers? Some 4 quick bullet points. There's pages on MDN about workers, so these are just some quick notes. But really, a worker is a script that runs in a different thread, not your main thread that's running your app. So it's kind of interesting idea to think about this power that you can run JavaScript in a different thread. You can communicate with a client app through messaging, which we'll see here in the demos. It acts kind of like a browser extension, so it sits between your client and your server, and you can do stuff to your client app with a worker. I do want to make sure it's very clear that it is not all roses. I saw this tweet not too long ago, and I had to share it because you buy a domain, you push the wrong service worker, and then you buy another domain. It's easy. There's a lot of pros to service worker. I mean, workers in general that we'll go through, but there is a steep learning curve. There are cons for sure. So everything has trade-offs, right? And workers are any different. You will experience some sticky cache, some where you're telling your users, well, just hit the refresh button, and they're doing Command R and nothing changes. They don't get the new assets or anything. There's no access to local storage from inside of your worker thread, you miss out on some window properties and you can't access the DOM either. There's little to no IE support, so if you're required to support that, make sure your app doesn't rely on your workers to run your app. And then there's a steep learning curve. When I was getting into it, trying to figure out how to register a file location with Webpack and Parcel, it takes adding plugins and configuring some config file stuff, and it can be difficult. And the steep learning curve is because there's a lot of lower level implementation, boilerplate type stuff that you need to understand so that you don't have to buy another domain. But pros, Hussein in his talk, and him and I have some shared points. There's a lot of performance stuff that comes from using workers in your app, like catching offline requests, pre-fetching resources. So before a user even clicks on something, you can go and get some resources and have that ready and served up. So if they do click on it, it gives this user this perceived blazingly fast experience. You can handle complex UI blocking functions, which we'll see with a web worker. And then you can do push notifications, and there's a sanitization between the messaging of your client app and your threads, so you don't have to worry about any safety concerns there. So for workers in general, there's some commonality between them. You can use normal JS syntax for the most part. There are some features that get a little fuzzy, but for the most part, you can use just normal JS syntax. They reference the JavaScript file, or for embedded workers, which is something else, you can reference just a script by updating the type to be JS-worker. You do have access to IndexedDB, and you work with WebSockets. I put the screen face because I think it'd be crazy to think of having a thread integrated, listening to WebSockets, and that conversation just seems interesting to me. I'd love for someone to build that and link and tweet me so I can see what you're using that for. But you do have access to WebSockets inside this other thread, so that is possible. Just a code snippet on how to get up and running with a web worker. There's a worker constructor that returns a worker object. The param is a string file location to where your JavaScript file that you want to load up in a different thread lives. And just like all workers, it has a messaging communication between your client app and your script thread file. There's two functions for the posting and the listening. It's post message and on message. You can use event listeners, just listening for a message in both your thread file and your client app. You can just register that event listener, and the callback function is how you receive and pass data back and forth. So this is a web worker. Now on to a service worker. It's pretty similar, but you register, again, a string file path to your JavaScript file you want to load in a different thread. And that's you call register, which is on service worker, which is in the navigator. This also uses a variety of event listeners for installing the service worker, intercepting the fetch request from your client app. This is how the caching works. And then also messaging, so you can intercept stuff, and then you can message between your app and the service worker through this message event. It works off of promises, so you can chain them, or you can use async await. There are a variety of Lifecycle events. You can think of it similar to React, where service workers have like an install phase, an activate phase, an update, similar to React. Understanding that where your service worker file is updating seems to cause the most confusion. For if you're trying to push a new asset, you don't see it being updated, that's part of that Lifecycle event. Really the true power, and this actually, Hussein was talking about this part, was working with the cache API and intercepting fetch requests from inside your service worker to provide not only cache results, but those cache results which provide a better performance, they also help serve up assets if you lose your internet connection. If you're unfamiliar with the cache API, it is the caching part of service workers. The service worker itself is not what's caching the stuff. It's doing the logic to retrieve and store your cached assets, but it itself is not doing any caching internally. That's done through the cache API, which is built into browsers. This screenshot shows that you can see that caching portion inside of the application tab, and on the left there at the bottom, there's the cache screenshot that shows where Workbox is doing some caching here. We're going to talk about that in a minute. This is the code to get a service worker up and running inside of your app. This is the React part or your JavaScript part. It's pretty simple. I've just got an if block here, checks to see if service worker is in the navigator. If it is, then we register a file. We chain a then, we'll wait for that lifecycle of ready to initiate. And then once that returns, we can add event listeners for messaging, other event listeners for when the service worker installs, and other stuff. So inside that second then is where we know we've registered service worker and we have access to it, we can start talking to it. I gave a lightning talk at ReactConf in Las Vegas, and this is a demo that I did there in my little 5-minute section where you can register a service worker, and you'll notice that I have the same Create React app running in 3 different tabs or browser. This is Chrome browser instances. And as you click on the app in each one, it's not only is it updating its local state, but then it posts a message to the installed service worker that's listening for that message, which then broadcasts a message to all other instances of your app that's running on that domain and tells it to update the state. So your state between your React app stays consistent as you click on each individual thing. Kind of a contrived example, not really sure where you would use that in your app. Maybe if you're like, inbox and someone's typing the draft, you wanted to keep that open across the tabs. I'm not sure. You might have something better to a use case for this, but this is cool. You have access to post a message, and your service worker will find out all the instances and relay that information to keep everything consistent. So a lot of power there with service workers. I did mention that it is a steep learning curve. It's not something you want to just throw in your app and push to prod, because there are some gotchas to it. And Hussein mentioned this Workbox library built by Google that helps us get rid of some of the boilerplate and some of the nuances of getting it up and running by giving us a simple API and some recipes that could just make it easy for us to use them in our apps today. Stuff like there's pre-caching, runtime caching, request routing, background sync, and helpful debugging. This is all built into and comes shipped when you work with Workbox for your service workers. So definitely check that out once you get in playing around with it. It's really easy to implement inside of your worker thread. Use the global import scripts function. You bring that inside of your worker file, and you just import, in this case, the CDN to Workbox, and then you have access to the global Workbox object there. So it's really easy to just bring into your thread and go crazy with it. It provides some simple and complex recipes, as I mentioned. Like we're going to see some examples here, but it's easy to just cache your assets right off the bat from multiple origins. Even if you're using a service worker and you receive an update, you can tell your user to update, or you can use Workbox to force them to update so that they get the new assets. And then you can provide a fallback response. So again, service workers can intercept fetch requests. And so if it sees a response come back that's a 404 or some other error message, it can, instead of relaying that onto the client, it can step in the middle there and say, you know what, here's the fallback image if something fails. So instead of it just airing out, you can pass through some type of fallback message, or I've seen this with Google Font. So if you have like you're trying to load some font from some CDN and it fails, you can switch it out with a different cached font. So able to utilize service workers for fallbacks as well. Just workers in general work with JavaScript stuff, so it works nice with React. It's easy you saw the code snippet. It's not you don't have to use Angular or React with it, but it does work good in React. Also, Hussein mentioned in his talk, Create React app in version 2, they offered an opt-in version. Before, I think it was automatically opted in, so everyone got it. But then in version 2, you had to actually change a little bit of code to actually opt in and have that as the default functionality. And inside Create React app, there's a bunch of code that does the caching, all of the boilerplate stuff, is already done for you. We'll see that a video of that here in a sec. But it's powered by Google's Workbox, this Workbox that we've been talking about, using a plugin called Generate SW with Webpack. So yeah, all the site assets are cached on a cache-first basis, and the app will work offline once you opt in to create React app. So let's see what that looks like. On the non-opted view, just a normal create React app. You don't have to do anything to it, just to see it. Like this is just running a build, starting a little server inside the build folder. Inside the applications tab, you'll see that nothing gets installed, right? Because we're not opted in. This is just a fresh create React app. All of your assets and HTML just come over the network. If you go offline and refresh, obviously it's going to break, and you get to play the T-Rex game if you want. This isn't great, right? It's not the best experience because you might run into a cactus or get hit by a bird, which kind of ruins your day a little bit. And I keep going, but I did eventually hit a bird. Create React app, the demo, the opt-in part is super easy. It's changing one line of code. You go from unregistered to register inside the service worker JS file, and that's it. All you have to do is just change that, and the React team's done a lot of boilerplate for you as far as the caching goes, including your assets, everything. So now when you do the jazz of running a build and starting a server, you'll see that a service worker is actually running inside the applications tab. You'll see a lot of Workbox JS that's working behind the scenes. And then once you refresh when you go into offline mode, everything still works. And you'll notice that your assets and your HTML and everything else is coming from the service worker, and you'll see that in the size tab. So the service worker steps in, sees that you're offline, and instead of returning an offline experience where you're playing the T-Rex game, it's serving up from its cache. So it works automatically for you. All you have to do is just change that unregistered to register. Again, another warning though, it's easy to forget when you've opted into a service worker, and I saw that this is from forever ago. Somebody on Reddit, and Dan Abramoff responded to help him out, but had the service worker working, reset their laptop, didn't realize what was going on, which is terrible, right? Like, you never want to lose everything that you have in your files because of a simple service worker running. And in my experience, it's always been something around like a sticky cache where you just check your laptop because you can't get anything to change even though you're refreshing. The damage was already done, but the user did figure out it was cached files. So it's easy to forget when you've got a service worker working, so make sure you keep that in mind. Some of the gotchas with the default create React app service worker file is that everything's kept in a waiting state, which means that in order for your users to get updated cached assets, they actually have to close their tabs in the browser. They can't just hit the refresh button. It doesn't work that way. So that could be a little confusing, a little complicated if you're like working with it, or your user's like, hey, it's not working. You can't just tell them to refresh. They have to close their tabs. They recommend having some type of statement that says new content is available when you close your tabs to help the user know what's going on. And there's documentation on how to put this message up there so that they know what's going on, and you know when they're stuck in an old cache. Some notes on this: when you do opt in, your app becomes a progressive web app. It can be added to your phone, an icon, link everything onto your phones, which is pretty cool. Again, that cache-first strategy for your assets, and it also does your navigation for you. However, if you don't like that functionality where you're doing that cache-first approach where you're telling your users they have to close tabs in order to update to newest stuff, you can't customize without ejecting right now unless you change to this different service worker plugin with Workbox called, I'm jumping ahead. There is a proposal and a pull request out there right now to add some type of Workbox config file so that you don't have to eject or you don't have to use a different plugin. But right now those are still pending with some changes. Though here you go. This is the way to have your Create React app work without ejecting. You have to switch out the plugin that it's using to inject manifests. It gives you control to have your content update without users having to close tabs. It's called skip waiting. It's pretty easy to add Create React app. You probably do it in like 10 minutes inside of your app. So it's a little bit of hassle, and it's a little bit harder to work with this plugin is than the Generate SW, but it is available for you until that proposal pull request goes through. Some final notes on service workers before we move to web workers. Again, that lifecycle method is important to understand that there's difference between it installing, installed, waiting, active. There's a couple more after that. And it's not transparent when it fails. So it's just going to fail silently in the background. You might not even realize you have a problem in your service worker. So something else to keep in mind on that. All right, so on to web workers in Create React app. Kind of similar to service workers, you have to eject your Create React app to really work with them. You can use a React app rewired in order to override some of the Webpack config stuff to add the worker plugin, which in my demo here in a sec, that's what I'm doing, is this bullet point 2. There is a pull request out for adding support as well, but that is also kind of sitting there waiting for some changes and stuff. So I'm going to show you like a little demo here for a thread blocking function. So here is some code, lives inside of the default app function of Create React app. We're going to calculate the Fibonacci sequence here. This is just a recursion function that figures out, given the number that you're trying to look up, it'll return the Fibonacci number in that sequence for you. So inside of our app, we use useState. We have a default value of 45. And that's what's passed to our Fibonacci function. So find the 45th number in this Fibonacci sequence. So this is going to call that recursive pattern until it figures out that 45th number. With that running in the background, I am unable to highlight this text or click on the Learn React button. It's entirely frozen. I can't do anything while it's trying to figure out the 45th number in the Fibonacci sequence. When that thread finally unlocks, all of my clicking blows up my tabs, and this is the number. This is the 45th number in the Fibonacci sequence. And my highlighting has come back. So this is what happens when you're running a lot of intensive stuff inside of your app, and maybe you're doing lots of changes to your DOM, or you're running some mutations to some data that you're getting back, and so it's causing a slowdown inside of your app. There's other ways around it, and in this case, we're passing it to a web worker. So really easy to just move this work into a web worker. It's like changing 3 lines of code, super easy. So inside of our app.js file, we're going to import the worker.js file. This is the file that's going to run in a separate thread. We're changing this stuff inside of useEffects. So everything else is the same, but inside useEffects, we're going to new up that worker. We're going to post a message to the worker thread saying start with the number 45. And then we're waiting for the response back from the worker with worker.onMessage. So whenever it does respond, we're going to take that message event and we're going to update our state to the data that it's passing back through that message event. And then inside of the test.worker.js, this is where our Fibonacci function is going to live. And then simply this is where it's going to receive, whenever it receives a message, it's going to post a message to our app with the number of the Fibonacci sequence. So pretty easy, super simple. Just took that logic out, threw it inside the worker. Now, when it's running the Fibonacci, I can highlight, I can click on everything, I could open up my React tabs, learn more about React. Everything's working fine. If we pause long enough, the worker will respond back with the same number. And there you go. So we've got our Fibonacci sequence. It did all the work in the worker, and then once it figured it out, it said, here main thread, here's the response that I got for you. What I've seen a lot from some use cases, some actual use cases for you. I was speaking at Magnolia.js earlier, and Ken Wheeler was doing a presentation, and he was using a worker to, alongside Yoga, which is, he made some like Canvas game thing, and he was sending some of the Yoga like layout stuff, and he pushed it all to a worker to do all that computation there, and then once it was done, it sent it back, and so he was able to have this really nice game that he was doing. So definitely use cases if you're using WebGL or Canvas type stuff to use a worker to handle all that heavy computation stuff. So notes on web workers, a dedicated worker, which is what we saw where you just knew up a worker inside your code, is only accessible by a script that called it. So unlike a service worker, where you can post a message and it knows and can spread out the message across different tabs, it only has access to the script that calls it. The shared workers is kind of like a service worker where now you can, but you knew it up differently. It's actually called a shared worker. And then you can close it out. You can close out that thread completely by terminating it with the terminate function on the worker. What's kind of cool is you can go inception on you and create sub-workers, so your workers can create workers. There is some value in spreading out logic if you can across multiple workers and multiple threads. So you do have that power. And as we saw with Workbox, you can import scripts from other CDNs. So you can bring in other JavaScript from CDNs or wherever else in your code and bring it inside of your worker to use. So you can bring in other libraries and utility stuff. So it's a whole other realm of an area where you can work with JavaScript stuff and go crazy with that and use it with your app. So yeah, finishing up with some tips and tricks here for you that I have as you start playing around with this stuff, because definitely take some time. There's not enough time in this talk to go really low level on these implementations. So at the end here, I've got a couple slides of references. Definitely check it out. I'm going to be posting it to my Twitter later on. So if you want to dig a little deeper, I'll show you where I'm hosting all the links. But some tips and tricks: test locally, run an incognito tab. That's going to help save you a lot of pain as you try to push new stuff. Incognito tab is not going to store any of that caching. It's going to install your service worker every time from scratch. So do that. Also, I didn't put it on here, but I should have. The DevTools is great. That application tab that we saw shows you what service workers are running. There's even an option inside your DevTools that shows service workers from other domains that are still running. You can force it to update. You can cancel it. The DevTools are awesome for working with workers. So that should have been another bullet point here. Because of that security issue with intercepting fetch requests in an app, it only works with HTTPS and localhost. So keep that in mind. And Workbox does have a CLI, which makes things a lot easier, especially if you're new and you want to dive a little bit deeper into it. Definitely check out the CLI there. So again, I have some links to references. There's so much information about workers, people using them for a lot of crazy stuff. Workbox has an advanced recipe section where there's some recipes on how to really go crazy with working with service workers and just some of the sheer power that you can do. I think in my experience, a lot of the stuff that you do normally, you just don't even think about. Maybe if you move this or cache that or have the user experience and the power that comes with workers, it just doesn't come naturally. So take some time, check out some of these, some links in Workbox, and yeah, let me know if you have any questions. Thanks.